The idea of flow in making things is very old. As far back as the 1450s, shipbuilders in Venice, Italy, used a moving assembly line to build ships piece by piece, creating a continuous flow of production.
But in the bustling Venetian arsenal of the 16th century, here shipbuilders pioneered interchangeable parts and a continuous flow assembly. In 1574, they astonished King Henry III of France by building a complete galley in under an hour, moving the hull down a channel past workstations. The idea of standardized parts spread. By 1765, French General Jean-Baptiste de Gribeauval championed their use for artillery. His vision was simple but powerful. If every part was identical, cannons could be repaired quickly, right on the battlefield, by swapping a broken piece for a new one. In England, by 1807, Mark Brunel created machines that made identical wooden rope blocks for the Royal Navy in a precise sequence. A few years later, in America, Thomas Blanchard designed a set of 14 machines that could carve complex rifle stocks from wood, passing the piece from one station to the next automatically. But a major problem remained. By the 1850s, American armories could machine metal parts, but only when the metal was soft. The process of hardening the metal warped it unpredictably. Every single piece then had to be filed by hand to fit, a slow and expensive process.
But it was an American innovator named Henry who truly mastered the concept in 1913. He combined three things: perfectly interchangeable parts, work that was the same every time, and a moving line that brought the car to the worker. He called it flow production, and it was a revolution. His factory could build a car in just 93 minutes. The problem? It could only make one product, the Model T, with no options, not even a choice of color. As the world changed, customers wanted variety. Other companies tried to offer different models and colors, but their factories became chaotic. Work was done in large, inefficient batches, and parts sat in huge piles, waiting.
1914, an innovator named Henry combined all these ideas. Using new, stronger steel tools and precise gauges, his factories could finally make hardened metal parts that fit together perfectly, every time. This was the secret to true, large-scale, continuous flow. The next leap came from an unexpected place, the German aircraft industry of the 1930s. To build complex planes efficiently, engineers synchronized every step of final assembly. The airplane fuselages moved forward in unison at a precise rhythmic interval, a concept they called takt time. After World War II, this idea traveled to Japan. A team of thinkers at a car company, led by Akio and Kenji, heard about takt time. They faced a unique challenge. Their market was small, and they needed to build many different kinds of cars on the same line. They integrated takt time with Henry's continuous flow, but added a crucial dimension: flexibility. By developing quick tool changeovers and a pull system where each step signaled its needs to the one before it, they could make small batches of different parts with very little waste or waiting. For decades, this incredibly efficient system was a well-kept secret. Then, in 1990, a researcher named James and his team published a book that revealed it to the world. They gave this philosophy, born from centuries of trial and error, a new name: Lean.
Lean. James and his team distilled the philosophy into 5 core principles. First, define what the customer values. Second, map the steps that create that value. Third, make those steps flow smoothly. Fourth, let the customer pull the value. And fifth, always strive for perfection. Today, Lean is not just for making cars. It is a way of thinking used in hospitals, software companies, construction sites, and governments around the world to remove waste and create more value for everyone.